Hello, welcome to Unit 4. Of course, we are also going to cover content of Unit 5 under the same unit, Program Control Structures. Last time we met, we were discussing the basic structure of Fortran programming. We went through how we can declare variables, the data types and the variables, and the different expressions like arithmetic expressions in Fortran. In this unit, we are going to cover relational expressions, logic expressions, then we'll talk about branch statements, if and the select case. The last section will be looking at the iterative statements, the loops. So there are three items to be looked at: the while, counting, and the cycle and exit. Before we go into the details of if and the while or the loops, we need to understand the relational expressions. Relational expressions are used to compare values. Remember, we went through some expressions before, and these were arithmetic expressions. These are expressions that we are using to add or multiply numbers or do some division, etc. So we gave you some arithmetic operators like plus, the minus. We had for the multiplication it was a star, then a division, then we had 2 stars to represent the power. If we want to have an exponent, we are using 2 stars, etc. So these are arithmetic expressions. So the data that we handle is not only arithmetic in nature. We have other data that we may also want to evaluate, and this is just one category, relational expressions. With relational expressions, we are looking at comparisons. Every day we have data which we make decisions by comparing maybe 2 items. So in programming, this is also very important, that you should be able to do some comparisons. So that category of comparisons, we call them arithmetic expressions, and they require we call them relational expressions, and they require relational operators for them to be evaluated. So here we are summarizing some operators. Same things that you've been working with in your maybe algebra course, only that the presentation is a little bit different in programming. For example, the equals here, this is equals to meet identity. Is this the same as this? So if you want to check if 2 are equal, 2 items are equal, maybe 2 numbers are equal, we use the equals, double equals. Because in programming, a single equals, like in Fortran, is used to assign a value to a variable. So for the identities, to check identity of 2 items, we use equals. You can also use this syntax. This is the old style of doing it, but I think it's good to use the new style. That would be better. So we have equals, we have not equals, not equal to, then greater than equal to, less than equal to. So this is how, these are operators that we can use to come up with the relational expressions. Here is an example. Given maybe a value of A to be 10, B 20, C 15, and D 20, we want to see different expressions of relational in nature and see what it will do, maybe evaluate to. The first one we are looking at is A. We can have them as questions. For example, is A equal to B? So if you look at A is 10 and B is 20, and this will return false because A is not equal to B. Is B equal to D? If you look at B, B is 20 and D is 20, so this will return false. Is A not equal to B? So if you look at A is 10 and B is 20, this should return true. A is indeed not equal to B. So etc, etc, up to the last one here. We are comparing values, and the result of relational expression will be either true or false. So that's what we are getting here. Another category of expressions that we have is that of logical expressions. And with logical expressions, we are not taking any other value to compare, but now we are taking the Boolean values. In other words, we are taking the true and the false values. So we'll be comparing them. The logical expressions, arithmetic expressions, we can compare values, we can compare numbers, we can compare text, etc. With logical expressions, we need a Boolean value or a logical value, maybe true, and compare it with another, or do some evaluation with another value of Boolean in nature. So we use these Boolean values to do different maybe evaluations of to come up with different operations. We look at the ANDing or the ORing or other operators that we have here. So we, in most cases, would want to see the truth. If we have the first truth and the second truth, such a statement, the logical statement, where the first part of the statement is true and another part of the statement is true, what should be the final? Should we have the final as true or false? What if the first part is true, the second part is false? What should be the final? So the statements to say, bring me maybe a cup of tea or coffee, or bring me a cup of tea and coffee, these are two different statements. And a person hearing such statements will exclude them different. For example, bring me a cup of tea and a coffee, it means this person is looking at both the tea and the coffee, so you have to bring both. But if you have a cup of tea or coffee, now you have options. You can bring maybe a cup of tea and coffee, or you can just bring one item, either tea or coffee. So such expressions have got also representation in programming. So here we are looking at some operators that we have. We have AND, or, equivalent, not equivalent, and not. Take note of the dots. We are starting every operation with a dot like that. So we have a dot. If we have this as the first true item and this as the second true item, and we want to AND them, if both of them are true, then the final result will be true. But if any of them is false, then final result will be false. But with the OR, if the first value you provide is true and the second value you provide is true, the answer will be true. If one of them is false, the answer will still be true. But if both of them are false, then the final answer will be false. This one is equivalent, is used to check if the first Boolean value is exactly the same as second Boolean value. So you cannot compare two Boolean values to say true equals another value, maybe another true as we are using here. No. If there are Boolean values in Fortran programming, you use equivalent to compare them. So if the first one is true, the second one is false, the final will be false. But if the first one is true and the second one is true, the final result will be true. Then not equivalent is opposite of that. The last one is a not, which is a negation symbol, and this negation symbol has got only one operand, so it requires one value, and it's written before the value. So if the value that you supply to it is true, then it will be changed to false. If it's false, it will be changed to true. So these are logical expressions that we need to take note of, and they will be very important. We are going to be using them to come up with so many other maybe decisions in Fortran programming. On their own, they may not make sense, the same with the group of relational expressions, but if we combine these ones with other maybe programming constructs, as we are going to see later, is when we see the power of them. We are going to be using them to make decisions in if statements, and of course even in the loop statements, as we'll see later in the chapter. Here we have examples of logical expressions where we are making an assumption that the first value is true, the second one is true, the third one is false. So if we say not first one, if this first one is true, so we are saying not true, then the final answer will be false, because it's not true. And if we take the first one, this one is true and this one is false, and we are using or, the final answer will be true. If we have the first one which is true, the last one which is false, and we are using and, the final answer will be false. And the rest of them, we are also using the same explanation that we had here. Okay, so we stop here for this video. We'll continue from here in the next video when we'll be looking at a branch statement. Thank you. See you soon.